Hello, my name is Wyatt Umlauf, and today we're going to discuss sound interference. First, let's discuss what makes a sound wave. Let's take our professor, and that's giving a lecture, and we measure a point 5 meters away from our professor. The displacement of the air molecules due to the sound is what creates the sound wave graph. The frequency of this measures a period, and the amplitude measures the volume. Let's look at another example. Let's say we have two speakers playing the same frequency, and we stand equal distance to both speakers. These sounds are going to overlay or create an interference, and we can make a separate graph for each of these sounds. Both graphs have the exact same period, so when overlaid, they almost match up exactly. We can create the resultant wave graph using a summation, which will then have a higher amplitude, therefore a higher volume. This is called constructive interference. An example of this might be with radio waves, where we might have multiple radio waves to create a stronger signal for our cell phones. Let's look at another scenario. Let's say we have two speakers again playing the same frequency, but we stand closer to the right speaker than to the left speaker. We can still create the two sound wave graphs, but we actually see that they are out of phase with one another. This means that the peak of one matches up with the minimum of the other. When we overlay them, it almost looks like the graphs themselves cancel out. When we create the resultant, it creates a much smaller graph with a smaller amplitude. This means that the volume decreases, which is destructive interference. If done perfectly, the volume is 0, and this is complete destructive interference. We see this with earbud canceling, noise cancellations, and earbuds, where the earbuds will play the same frequency as outside sounds but out of phase, such that it cancels the noise. Let's take another example. Let's say you have two speakers both creating different frequencies that are almost the exact same. We can create the two separate sound graphs, which almost look the exact same, but they actually have a different period. When we align these two together, we see that the resulting graph is going to have constructive and destructive interferences at different points. The resulting graph is going to have a changing amplitude, which means a wobbling or change in volume. This is called beat interference. These beats, or the change in volume, is measured by the difference in the frequency of the two speakers. An example of this is with tuning instruments. Let's say we have a reference pitch and an instrument we want to tune. As the beats slow down between the two, this means that the differences in frequency lower, and so they're becoming more in tune with another. Thank you so much. My name is Wyatt Umlauf, and this is Sound Interference.